Hello, I'm Mike Freeman, Project Engineer at WMG, which is part of the University of Warwick in the UK. In this presentation, I'll be telling you about some of the challenges that we've encountered whilst developing a scenario database for the Midlands Future Mobility Testbed in the UK. In particular, we'll be taking a look at decisions we've taken with scenario definitions and labelling in an attempt to future-proof the database in the new and fast evolving world of CAV testing. So let's start with some background and context to the database. The database is part of the Midlands Future Mobility project in the UK, which is a government-funded project to create an ecosystem to support the development of connected and autonomous vehicle technologies. The testbed offers CAV developers facilities for testing in virtual environments, as well as 300 miles of monitored and 5G connected real roads in the Midlands. The testbed aims to accelerate the development of CAV technologies by providing a range of services and facilities to organisations developing CAV technologies in order to get the technologies out into society quicker. So the role of the database in this testbed is to provide an extensive database of test scenarios which can be used for testing CAV technologies. It will achieve this by facilitating the sharing of scenarios between organisations, regulators and researchers. Users are able to access the database via a web application, and also there is an API which allows organisations to connect their existing ADS testing infrastructure to the database so that they can download scenarios and test with them. The database is not a system in isolation, but needs to be viewed as a wider part of the CAV development community. So it's important that the database can interact and interoperate with other systems. To encourage organisations to invest their time into the database needs to be built using standardised methods for the representation of scenarios and for the interoperability with other systems. The nice thing about standards is there are so many to choose from, which is true for established industries, but however we do not have that luxury in the world of CAV testing, with it being so new. At the moment there are no universally accepted standards for scenario definition and labelling. However, at WMG we are taking a leading role with the standard bodies ASAM, BSI and ISO in developing new standards required for CAV testing. Being involved in these standards activities means that we have a good feeling for the shape of the eventual standards, but we can't be absolutely sure what those standards are going to look like. So the challenge of designing a database which needs to be standards based without knowing what the standards will be is a real challenge. So let's take a look at scenarios now. So a scenario defines essential elements that are required for a test. So that covers things like the road layout and features, environmental conditions such as the weather and lighting, and dynamic elements such as traffic and pedestrians. Scenarios can be defined using a scenario definition language. Many organisations have developed their own private SDLs. At WMG we have developed an SDL which is intended for public use, a bit of which you can see here. The WMG SDL is a high-level language which is suited to defining functional and logical scenarios in a syntax which is both human readable and machine readable. And that is why we've selected it to be the primary method for defining scenarios in the database. It is simulator independent and can be translated into simulator specific code. We have developed a toolchain which will take scenarios in SDL format and execute them in the Kala simulator. We will also be working on a toolchain which will take SDL and translate it into OpenScenario and OpenDrive to give wide compatibility with existing tools and systems. So to future-proof the database, it has been architected to allow for multiple scenario definitions to be held against a scenario should a new standard need to be supported or new versions of the standards released. So we can see here we've got a definition for a fairly simple scenario, but you could imagine how long that would become for a more complex scenario. By necessities, SDLs have to contain enough information required to execute a test, so they can become quite lengthy. Extracting key information from a scenario in order to understand what it represents is non-trivial, but necessary if we want to be able to organise and manage scenarios within a database. It's no use having a million scenarios in your database if you can't search for them and identify which ones are relevant to your testing requirements. So this leads on to the question of how can we search scenarios in a performant way? And that brings us on to the subject of scenario labelling. So labelling is the process of creating a descriptive set of data about a scenario, which can include data that is explicitly contained in the scenario, data which is implied by the scenario, and also data which can't be expressed in the scenario, such as extrinsic data like who authored the scenario. Because the structure of a set of labels is far simpler than a scenario definition, it means that data is far easier and quicker to process than that in a scenario definition, which means that is a lot easier and more performant to query on a label set rather than a scenario definition, and also a lot easier to perform analysis, such as looking at the scenario coverage in the database. So the question comes to what set of labels should we use? So following a standards-based approach, we have chosen to align the database with the ASAM Open Label Standard, which is currently being developed by an international group of industry stakeholders. It is being developed to address the broad needs of the CAV community in labelling scenarios and for annotating real-world captured data. Critically, Open Label contains the BSI PAS 1883 labels for defining operational design domains for CAVs. So that means that when testing, it will be possible to search for relevant scenarios in the database using the same terminology that has been used to define the domain for the CAV being tested. As well as ODD labels in the Open Label Standard, it will also cover the behaviours of actors within the scenarios and also allows for metadata for adding additional information about the scenario. Separating out the storage of labels from the scenario in this way gives us the opportunity to design in a way which is labelling standard agnostic and allows for the possibility of using multiple label sets for a scenario, which further aids to future-proof the database should new labelling standards need to be supported. And in fact, using this technique has given us the ability to allow users to extend the labels for their own purposes. So we see a search example here from the database where we are searching using labels, and we can build up quite complex searches with logical operators, ranges of values and exclusions. So using a label set to represent the content of a scenario will give the ability to search on scenarios for the presence of things like junctions, weather and the presence of other road users, as well as specifying extrinsic metadata. What it does not give, however, is the ability to perform searches which involve the relationships between elements in a scenario. So for example, if we wanted to search for scenarios which had a lane closure on the approach to a junction, then searching just for the scenarios that contain a lane closure and a junction would return all of the scenarios that contain those features, but the lane closure may not be anywhere close to the junction. And that's because the labelling set does not include any data which relates the lane closure to the road approaching the junction. What is required is the ability within a label set of being able to define the relationships between the labels. So in our example, we would need the label sets for the scenarios to include relationship information for the lane closure and the junction. To do this, we need more than just a labelling taxonomy. What is required is an ontology. So an ontology builds upon a taxonomy by defining the types of relationships that can exist between the elements. Relationships between elements in a scenario can be expressed using RDF triples, where a subject element, such as in this example, car A, is related to another element, car B, by the relationship is following. Going back to our previous search that we wanted to do, the relationships between the junction and the closed lane could be represented by an RDF triple in the label set, which would then allow us this information to be searched on. So by including triples in our label set, we can give the user the ability to perform more complex searching. RDF triples are usually stored in a specialized type of database called a graph database, which are optimized for triple storage and have a querying language specifically designed for querying triples. For our database, we've based our label storage on the graph database functionality within Microsoft SQL Server, which enables us to perform these relationship type searches. So with storing scenario elements and relationships in a label set, the label set actually becomes a step closer to actually being a scenario definition in its own right. And that raises the question of where do we draw the lines in terms of the richness of the label set. But that is an open question. So the development of an ontology for use with CAV testing is currently an ongoing activity by ASAM, in which WMG are involved, and we will be enhancing the labeling and searching capability of the database with the output from this project. So bringing it all together, we have attempted to future-proof the database by largely trying to develop it to be standards agnostic, but by supporting the standards that are emerging. The database supports Open Label and WMG SDL with the potential for supporting multiple scenario labeling schemes and scenario definition languages. Should new standards emerge, they will be able to be accommodated alongside the existing ones. So to facilitate scenario sharing and compatibility with existing tooling and systems, scenarios can be downloaded from the database or accessed via the API and retrieved in the SDL format and Open Scenario 1.x formats. Labels are retrieved using the Open Label standard, and the actual format of the files themselves are in JSON and will also adhere to the Open Label file schema that will be defined. Scenarios that are downloaded from the database that have been put into the public domain will be licensed under the Creative Commons license agreement, which means that the scenarios can be freely used. Okay, so just looking at the timeline for the database, we started developing it back in last November, and it's currently in a beta trial with stakeholders from across the world, and we're continually developing it based on the feedback that we're getting from them. And we're looking to release the database for general availability next year, sort of February to March time. So if you are interested in taking part in the beta trial and contributing to the database, then please get in touch with us. So that concludes my presentation. I hope you found it of interest, and thank you for listening.